Hello and welcome once again to Isabella's explanation of math things. Today I will be going over a problem from Unit 4, which I do not know the name of, but Unit 4. The problem reads, work with your team to find two different ways to solve x minus 2 squared plus 4 equals 2x plus 3. Be sure to explain the logic of each of your methods and show that the solutions are correct. Well, let's begin by looking at what we have in our equation. You can see that this side is a quadratic function because the variable is squared. It follows the format of the parent function for a quadratic. And since quadratics always make parabolas when graphed, we know that this equation will sort of look like this when we graph it. On the other side of the equal sign, we have a linear function. Again, remember the format of the parent function for a linear. The graph for this type of equation looks more or less like this. So now that we know what we're dealing with, we can begin to solve. The first thing we should do is make this equation equal to 0. So first we'll write it out. On the left we have a pair of parentheses, so we'll get rid of those by factoring the expression. Now we're left with x squared minus 4x plus 8 equals 2x plus 3. Let's get rid of everything on the right to end up with 0. Subtract 3 from both sides, subtract 2x from both sides, and now we have x squared minus 6x plus 5 equals 0. Does this equation look familiar? When something is equal to 0, you can use it in the quadratic formula to get two values of x. This equation is pretty simple though, so we can skip performing the quadratic formula by factoring, like so. Then we can ask ourselves, what values of x will make this expression equal to 0? What minus 5 and what minus 1 equals 0? Well, 5 minus 5 equals 0 and 1 minus 1, so our two values of x are 5 and 1. So what do we do with these two numbers? Well, let's go back to our original expression. Remember this linear function? We can use it as an equation into which we can plug in our x's. Let's bring it over here. Y equals 2x plus 3 becomes y equals 2 times 5 plus 3. 5 times 2 is 10, and 10 plus 3 is 13. So for this equation, when x is 5, y is 3. That becomes our first solution, 5, 13. We still have one value of x left, so let's do everything again. Y equals 2x plus 3 becomes y equals 2 times 1 plus 3 plus 3. 2 times 1 is 2, and 2 plus 3 is 5. So our second and final solution is 1, 5. For this equation, when x is 1, y is 5. Well, that's one way of solving this, the algebraic method. A second method would be to solve this graphically. It is what it sounds like. We graph both functions and see where they interact. Let's begin by graphing our quadratic equation, x minus 2 squared plus 4. We can already tell, just by looking at it, that the vertex of our parabola is going to be 2 spaces to the right and 4 spaces up, because our h is negative 2 and our k is 4. We also know it's a normal-sized and shaped parabola because our a is an implied positive 1. Knowing this, we can draw a rough sketch, but it's best to use a table to make sure our graph is accurate. I've made a table on the side for the sake of time. This is what your graph of x minus 2 squared plus 4 should look like. Next, we graph our linear function. You probably remember how to do this, as indicated by the equation. The y-intercept is 3, so our line will cross the y-axis at this point. We also know the slope is 2, so we can count up 2 over 1, up 2 over 1. At the end of this process, your graph should look like this. Since we graphed our functions on the same graph, we can find the points where they intersect. There are two places of intersection, and these just so happen to be 5, 13 and 1, 5. See? These are the same solutions we got algebraically, only we did it by graphing the functions. And there you have it. Now, as you know, math isn't actually real life. This YouTube video right now isn't real life, but as all the math teachers say, there is a way you could apply this math to real life. In the case of these equations, a statistician, someone who works with statistics, might use them to find the correlation between two different sets of data. This also applies to people who work with plants, history, education, sciences. It's important to find the connections between the growth of oak trees and maple trees, or something. You know what I mean. Finding the intersection between two types of data. So yeah, I guess this is the end of the video. Do your homework. Isabella, out.